Hey guys, so today we're going to kind of continue our talk on functions. So far in my class, we've talked about two different types of functions. We've talked about linear functions, obviously that make a straight line. And then before we left, we talked about quadratic functions. So let's kind of review those a little bit. Remember, we can talk about functions in four different ways, either word problem, equations, tables, and graphs. So the first thing we're going to look at is a review of linear functions. So here's an example of a linear function. So the word problem says you are driving to visit your best friend in Gulfport. Since you have a long drive ahead, you turn on cruise control. So cruise control keeps your car traveling at a constant rate of 60 miles per hour. And so the equation is here, 60 times h, with obviously h being our hours. And we know that it's going to be linear because of this keyword, constant. Anytime you see something talking about a constant rate of change, most likely it's going to be a linear equation. So what's here is a table. So after 1 hour, we've traveled 60 miles, 2 hours, 120 miles, and so on. So your f of h, or your dependent variable is increasing by 60. And you'll notice that when we graph it, it also makes a straight line. So the second type of function we've looked at are quadratic functions. So let's read the verbal description. It says you are observing the height of a ball and it's dropped from a 150-foot tall building. Because of the force of gravity, the more time that passes, the faster the ball travels. The ball does not travel at a constant speed like your car on cruise control. So obviously there's some keywords here that tell me that it's not linear, not a constant speed. But the key thing we've talked about in the past is that gravity is going to affect that ball and pull it down faster as time goes by. When we write this equation, the negative 16 comes from that force of gravity. T is your time squared, and then 150 is going to be your y-intercept, or the starting point. In this case, where the ball is dropped from. So if we made a table, obviously if we added one more line to this table, at time 0, we would be at 150. Then after 1 second, if we substitute that into my equation, I'm at 134 feet above the ground. After 2 seconds, I'm 86 feet above the ground. And then after 3 seconds, I'm 6 feet above the ground. So you can see here, it's kind of like the right corner of that parabola, an upside down parabola. And it looks like eventually that ball would hit the ground a little bit more than 3 seconds. Okay, so let's look at a new type of function. This one's called exponential functions. So let's talk about some keywords. So here's the verbal description. You are performing an experiment in science class in which you start with 100 bacteria, and the amount of bacteria doubles every hour. So the thing that in this problem that tells me it's going to be exponential is that word doubles. So you may see something about halving, doubling, tripling. We're going to talk about some money equations, but those are those keywords that tell me that there is some sort of exponential function. If we look at this table, it's not increasing by a constant rate, but what's happening is it's multiplying by a constant rate. So to get from 100 to 200, you're multiplying by 2. From 200 to 400, you're multiplying by 2. And that is constant throughout. So we're not adding the same number like we would be with linear. We're multiplying by the same number. And that's how I know it's exponential. And if you look at this graph, you'll notice it kind of looks similar to a parabola, but we're going to show some examples to where this side of the graph ends up just going out almost to a straight line, never crossing 0. And that is something we're going to talk about. And it's going to keep going up and up and up this way. Okay, so let's try and figure out how we can find equations for these exponential functions. So each time you have an exponential function, we're going to write it in the form a times b to the x power. And that looks a little different. We've never had variables as our exponents, but that's how you know that it's some sort of exponential. So remember with linear, we had y equals mx plus b, no exponent. For quadratic, we had ax squared plus bx plus c. That squared was our exponent. And so for exponential, our x is actually going to be our exponent. So we got to look for these two key things. Our a value is always going to be our y-intercept. So we could find that from a graph or from a table. In this case, it's in the table. Remember, our y-intercept is when our x value is 0. So in this case, our a value is going to be 4. Okay, and then we need to figure out that b value. So your b value is something we're going to call a common ratio. And what that means is, how are my y values changing? So if we look here, we're going from 4/3 to 4, from 4 to 12, 12 to 36, and 36 to 108. So when we're talking about exponential functions, remember we need to be multiplying by the same value. And all of these are multiplying by 3 every time. So 4 times 3 is 12, 12 times 3 is 36, and so on. So our common ratio is going to be 3, and then our exponent is always going to be that x value. And that is what the equation for that exponential function is going to look like. So let's try another one. So here's an exponential function. It looks a little bit different. So I hope you realize that our equation, what's involved is not just necessarily going to be two positive whole numbers this time. So instead of the previous one, my graph was going up, it's kind of flipped around. So let's first talk about our a value. Remember, a value is our y-intercept. And we can find that from our graph or our table. Sometimes if a table is given, I find it easier. We just need to look at where our x value is 0. So our y-intercept is going to be 2. And you'll notice on this graph, because the scale is so large, it's kind of hard to tell that that's exactly 2. So I would suggest looking at the table. And then we want to see how our y's are changing. We're going from 4 to 2, 2 to 1, 1 to 1/2, 1/2 to 1/4. And it is being divided. I realize that, divided by 2. But we want to talk about that in terms of multiplication. And remember, when we're doing our common ratio, our b value is common ratio, we want to make sure that we're talking about what are we multiplying by. Remember, dividing by 2 is the same thing as multiplying by 1/2. So our common ratio is 1/2, and it's to the x power. And you'll notice that this exponential function is heading downwards, and that is because of that 1/2. Before, if we look back, this was a positive number, a positive whole number, not a fraction, excuse me. So it's heading upward, those getting bigger. But because we're taking half of our numbers, we're now getting smaller and smaller and smaller. All right, let's look at one more. So we're going to match here. We have 4 different exponential functions, and we need to decide what graphs they're going to go with. So we have this first one looks like it's heading down, heading down, heading up, and heading up. So we first want to look at our y-intercept. So this function's y-intercept may not be obvious, but I'm going to rewrite this as 1 times 3 to the x, because we still have that imaginary 1 out in front. This y-intercept is 2. This y-intercept, although not obvious, is going to be -1. And then this one's y-intercept is obviously -2. So let's try and find this first one. Which one of these has a y-intercept of 1? It actually looks like this last one. So we're going to say f of x equals, and I'm going to write the whole thing, 1 times 3 to the x power. And that's the only one that crosses at a y value of 1. This second one, we want to find out which function crosses out a y value of 2, or y-intercept, and it's this one. So we have f of x equals 2 times 3 to the x. This third one, which one of these crosses at -1? That's the second one. So that would be f of x equals -1 times 3 to the x. And then obviously the last one is going to be f of x equals -2 times 3 to the x. And that's because this one is crossing at -2. All right, let me know if you have any questions at all, and I look forward to hearing from you guys. Bye.